Hello everyone, my name is Krishna Prasad and I am from mechanical background. And today in this video session, we are going to discuss about the involvement of automation in manufacturing industry. Okay, so first start with a topic like what is a manufacturing? What is a manufacturing process or manufacturing technology? What actually the manufacturing? Manufacturing is nothing but it's a conversion of raw material or semi-finished goods to end products or outputs. It's nothing but the process known as a manufacturing process. So where exactly this process will be helpful? So in every industry, if you take any example, so if you take the examples like some industries, they are taking the raw material as a powder. Some industries will take the raw material as a steel. Some it will take as a blocks, and they are converting that into a useful equipment, like some dies, like some keys, like some other objectives. They are called as manufacturing. For this process known as a manufacturing process. Like some industries are taking semi-finished goods, like they are taking some cylindrical bars which will be fabricated by some other industry, and they are purchasing that, and they are doing the operations like threading operation, doing some other operations, and they are performing their outputs. They are taking it to their outputs. This is also known as a manufacturing process. So simply manufacturing process is nothing but it's a conversion of raw material to end product goods. So whether the raw material will be the original raw material or it may be semi-finished goods. Okay. So if the production is large, if I want to prepare one or two objects, then no problem. I can use directly simple machines or conventional or CNC machines. If at all my production is large, so for us, let us take example. So in the 24 hours, I need to complete some 1,000 number of work pieces. So I need to opt which one, the numerical one, or sorry, conventional one, or the computer numerical machines. Which one I need to prefer? So I'll be preferring CNC machines. Why? Because for getting higher production rates, flexibility, higher accuracy, and everything. So I'll prefer CNC machines for getting higher outputs, for getting a quality related, quantity related products. If my industry is having a large number of machines will be there, and the production rate is also higher. Okay, I need to produce some 10,000 units or 20,000 units daily. So then at that point of time, so we are using conventional machines or CNC machines. If you are using conventional CNC machines, what will happen? And who will going to work over the machines? Obviously, workers will going to humans will going to work on the machines, whether it is a conventional machine or whether it is a CNC machine. The humans need to interact with the machines and need to give their operations to the machines. If it is a conventional machine, you need to operate the machine. If it is a CNC machine, you need to program the machine. You need to change the machine. You need to change the work pieces. You need to change the work environment, everything. Then only we'll get the production, we'll get the productivity. Okay, output objects. So this is a process. If at all my industry is large, my industry is having large number of machines and my production rates are high, then how come I supposed to increase my productivity? If at all I'm getting X output with all these machines, CNC and conventional machines, and I'm having workers, W type of workers. So how to increase the productivity? The only way is to automate the process, which means the automating is nothing but so removing the lagging process, removing the process which will be time taking. So let us take example material handling. So let us take the example of material handling. So if the raw material need to be handled by a worker, he need to lift the work pieces, he need to pick the raw material and need to place it in a cabin near the machine, and the worker which is at the mission need to work over there. Once the output is ready, and he need to take, and some other worker will come and take that workpiece to some other mission, and he need to continue the process. So now there will be like 4 missions will be there, and 4 separate workers will be assigned for operation only, and all the operating outputs. So from mission 1 there will be output, mission 2 there will be output, mission 3 there will be output, and mission 4 there will be output, and mission 1 output need to be carried to mission 2. That is the mission 2 input. At the same time, mission 2 output is the input for mission 3, and mission 3 output is input for mission 4, and workers need to be carried that mission 1 output to mission 2 input. At the same time, some other worker need to carry mission 2 output to mission 3 input. So what will be happen here? The worker need to take the workpiece from station 1 to station 2. So the time is wasting here. So if at all I'm getting with this type of process, with this number of workers, with this number of missions, with this type of CNC missions, I'm getting X output. Okay, if at all I want to increase that output X to Y, then what are the common factors? Whether I need to change the process of the mission, okay, or there is another method. If we automate the process, which means instead of putting the workers to transport that output to the second machine, I'll prefer some conveyors. So what will be happen? The conveyors will be automated. So they will run automatically. So if I place my object on the conveyor, so automatically it will travel to next station. So without any effort of human. So what will be happen here? So there will be loss. There will be the time taken for the process will be less when compared to the human effort. So if at all I increase this complete conveyors for these 4 missions, then what will happen? Obviously my output will be increased from X to X1 or X2, X3, whatever it may be. Okay, but the increase of output will be observed with this type of thing. So automation is nothing but, what is automation? So automation is nothing but creating the automated processes in the industry. So it is not a big automated parts, simply like conveyors. So if you are trying to carry our parts from station 1 to station 2, simply use conveyors, or we use trucks or whatever it may be. So we can use that for transportation, material handling. So that is the first part of the automation. So now I think you all know the importance of automation. So now I will tell you the definition of automation. Automation is a term applied to all the measures taken which will cause a process carried out on its own or accordingly to the previous set of program without intervention of humans. Automation is, again, I will tell you what is automation. Automation is a technology that concerned with operation of mechanical, electronical and computer based systems to operate and control production. This is a brief definition, but I will tell you in clear. So what exactly the automation will be referred? Automation is nothing but it is a, if we consider automation as a production, so if we tell automation is a mass production applied to industry, then automation is nothing but we are substituting the workers with some mechanical machines, and we are substituting the human process with some mechanical control. That is nothing but automation. Simple, in other words, automation is nothing but it is a process that tends to increase the productivity of the industry by substituting humans with automated machines or automated control units. Okay, this is nothing but the concept of automation. Here I'll tell you why exactly we are using automation in all industries now. So okay, so let us tell you how exactly this improvement rises. So initially we are going to use some conventional machines for our manufacturing or production. Right now we are using the conventional machines. So at that time the innovators won't stop at that point. Why? Because they are getting the output, but they are not getting that desired what they desired. Okay, so if I am having two conventional machines and I want to get some X output, but I am getting only some A, B, C, whatever type of output, but not getting this X type of output, then the innovation rises, and that point of time, that mission, there is an improvement from conventional mission. That improvement is nothing but numerical control missions, NC missions. What exactly they are there? So instead of doing manual work, their numerical control, what will be done? There will be a programs will be there generated on the tapes will be there. The program will be converted into the tapes, and tapes will be into run into the machine. So the program will be created. That is an automation. And from, if I am having two different missions, NC missions, then I will get some C type or D type of output. Okay, which is far greater than A and B type of outputs. Okay, at that point of time, numerical control missions, there will be again the innovations will be there. So many innovations. Because of the innovations, they have risen to NC missions to CNC missions, which means computer numerical control missions. They have integrated computer to the numerical controls. So they have taken all the magnetic tapes and everything, and they have created new concepts like G codes and M codes. They are preparing the complete. They have changed the complete manufacturing concepts with this CNC technology. With the CNC technology, what will happen? The production rate will be increased rapidly. So if I'm having two different missions, two CNC missions, and I want to get X type of output, then I am getting almost M or N type of output. Why? Because it is a far superior than conventional or NC missions. So I am getting some N type of output from CNC missions. Again, the improvement won't stop. From CNC mission, with the improvements, they are converted to DNC, direct numerical controls, which means a simple large monitor, large computer system, server system, which includes all the missions, all the CNC missions in it. So I am ready to store the programs. If at all I want to run a program in a CNC mission, particular CNC mission, A CNC mission for 100 outputs, and I want to run on B CNC mission 1000 outputs with some other program, then I can directly operate from DNC. then the production rate will be increases. Now I am getting with the if I am having a DNC machine and some CNC machines, I am getting like O or P type of output, which is somewhat greater than CNC machines, and there the innovation never stops. And from that CNC technology, and the innovation will be raised to some other. If at all I am increasing the material handling, okay, now the machines are running perfectly well, but the delay is on the material handling section. So for the material handling, they have improved to material handling system, automated material handling systems, or automated processes, or nothing but conveyors. They have implemented conveyors in between these machines, in between these process, from raw material to output. They have completely implemented conveyors. So now what will happen? My output is raised to P to Q type, so somewhat greater than the previous one. So I'm getting the desired output, which means so the material handling time will be here decreasing, and the more the production rate will be increasing because of the material handling, and the less and because of the low involvement of workers for this transport, my production rate will be increased in this conveyor type technologies. And there the innovation never stops, and from automated parts or conveyors, there the automation starts. What exactly the automation is? Here the automation plays a crucial role here. So this automation is testing all the machinery process, all the industry process, and I have prepared a task for checking. So for creating automatic parts, for creating mechanical components, for mechanical, electronic or computer based systems to replace human efforts, for getting higher production rate, for getting the inspection rate faster, for getting higher dividing rate faster, or everything. So because of this automation, I am getting a production rate of output rate of S, T or T type, which is far superior than previous types with the involvement of automation. So with this, automation plays a crucial role in this industry process, in the manufacturing process. But I want my desired output at X level, but still I am at some S level. So there will be still some gap is there. For completing that gap, now there will be process like involvement of new robots, involvement of robots in this technology. So with this involvement of robots, and robots are going to use some other operations, material handling operations, painting applications, welding applications, different applications, and they have reduced the time, and they have increased the productivity to some W type or U type or V type. Okay, so now we have reached up to U type or V type, which is almost nearer to the X type, but not the same, but not at the X level, which means still there is some more innovation. Now we are at U type or V type. So with the involvement of automation as well as robotics, conveyors, DNC, CNCs, everything, we are getting U and V type of output. Still there are some more innovations will be running all over the industries, all over the scientists are running some other improvements for getting that desired X level of output. So the technology won't stop. Now in this topic we are going to discuss about the automation. According to the automation is nothing but it's a logic and a programmable language. So if you are doing some task, if a human is interfering and he is doing the task, with the human interference the time taken is T. With the involvement of logic and programming over there, in the substitution of human, then we will getting some other output which is far superior than the previous output. So here we are using the automation as a concept, automation as a base for these production units. So now according to the textbook definition, what exactly the automation is? Automation is nothing but it is a term which is applied to a measure taken that will cause the process, that will change the process, that is carried on its own or on the base of the previous one. So if at all a process is going on, now I need to implement the automation over there, which means that process need to be done on its own, or it will take the help of the previous process. So it will going to take on continuously. That process is nothing but an automation. And in this automation, what are the things that will become into role? There are like missions, mechanics and control technology. With the combination of missions, mechanics and control technology, we will implement this automation. Okay, I think you understand this concept of automation technology and automation in industries. So why exactly we are using automation again? It should have an ability. So before taking the automation, so it should take the challenges. So if at all it run on its own, it should take its own rules. So if at all it should have its own ability to take the decisions, whether if I am using a conveyor and the second conveyor from mission 1 to mission 2. Mission 1 is producing some type of outputs and conveyor is traveling those outputs to mission 2. For some causes mission 2 is not working. So what will be happen? The conveyor will be full of this work pieces. At the same time, what will happen? Mission 1 will continuously run and the new product will go into place on the conveyor, but mission 2 is not running. So at that type of time, what will be again? So the conveyor need to give that decision. Conveyor need to give the feedback to the mission 1 that mission 2 is not working, so you need to pause until the next run. So that decision need to be taken by that decision should be carried by the automation only. That all can be carried by control technologies or programmable logical controls, sensors, actuators. Well, there are many concepts, many aspects in this automation technology. And after taking the decision, carrying the decision throughout the process. So if at all the process is continuously running for a 24/7 for a 1 week, so that decision need to be carried for 24/7 for 1 week. Then only that automated system is completed. Okay. So this is what exactly the automation is. In other words, automation is a technology that concerned with operations of combination of mechanical, electronical, and computer-based systems to operate and control the process. Which means missions are running on its own. Okay, there will be no need of any human interface, but the worker need to be there for changing the. If at all you need to change the program, then only the worker need to be for the mission. Otherwise, what will be happen? Automatically mission 1 will mission and the worker will come in on the mission and run the program. Same mission 2, same mission 3, mission 4. Then what will happen? Automatically, if at all the output was ready, the output 2 was generated to carried over to the conveyor and it will travel all the way to the mission 2, and mission 2 automatically the process will be started once it will get the output from input from conveyor. Like mission 2, 3, 4. So all these processes were automated with the help of sensors, actuators or controls or PLCs. So now I am discussing about these 4. So these are the different aspects in the automation concept, which means here some of the aspects of the design and fabrication. So if at all I want to prepare automation in my industry or in any other industry, we should follow some type of design for the automation also. Everything is a pictorial, so we need for separate design for this automation also. Some of the aspects of the design. So if I want to put some design in this automation plant, in this assembly line, then I need to put some devices like sensors, actuators, microprocessing units, PLCs, electric drives, mechanism, pneumatic or hardware, hydraulic systems, CNC technologies, and many other AGVs. These are all like devices, components of automation. With the help of these equipments like sensors, if at all there is a, like I already previously explained you, mission 2 is not running and continuously mission 1 is running and the output is generating and the conveyor is running and conveyor is full of material, then what will happen? Automatically after filling the conveyor, then because of the sensors or actuators, this conveyor will give the feedback to mission 1 to stop the mission or to pause the mission, to rest the mission for the next time. Then only then what will happen? After generating the signal, automatically some red light or based upon the availability of the worker, based upon the mission characteristics, the light will be on, and after seeing that, the worker will come and solve the problem. So this is how the automation will works here. And majorly the automation includes automatic mechanical tools or mechanical parts for processing parts, automatic machining tools for processing parts. So what exactly is this? So if at all I want to run this program, then I need some hydraulics. If at all I want to drive my workpiece from one place to another place, then I need some jigs and fixers. I need some pneumatic drives. I need some hydraulic drives to drive that. So I need some automatic mechanical tools for process plants. And second one is automatic assembly missions. If at all I am having an assembly mission, assembly line is there, then same thing. I need to differentiate. I need to use these components to divide these components in the missions. Automatic material handling and storage systems. So these are some of the aspects. These are also some of the aspects. And feedback control system is one of the main thing in automation. So without the feedback, there will be no any automation. Why? Because if you are generating some signal, generating some output, and it should be carried to the previous one, then only it will be run on its own, on exactly without any delay. And again I am telling you what is exactly the automation is. Now I am giving you a simple idea. So automation is nothing but if it I already explained you regarding this one. So automation, if we at all we are considering automation as a mass production, then automation is nothing but it is substituting the human workers and human efforts with mechanical missions and mechanical control to make the process complete. This is nothing but a automation. Okay, and there are different type of automations will be there, like fixed automation, programmable automation, flexible automation. Okay, if at all I'm talking about the fixed automation, what exactly the fixed automation is? The name itself indicating fixed automation. Fixed automation is nothing but, if at all my plant is having some 100 machines and it will going to produce 10,000 items, 10,000 objects per day, then it should be run on a simple same cycle on a fixed program. Then this automation comes into place, fixed, with having only one program with higher accuracy tasks. That is nothing but a fixed automation. When coming to the programmable automation, what exactly the programmable automation and where exactly it is used? So if at all my plant is having some batch production, so I want to produce some batch production, okay, some 100 outputs or 500 outputs, only 500 outputs, then only for that type of application, for that type of production, only separate working instructions will be there, separate working conditions will be there. For that conditions, automation can be performed by using programmable automation. Then what is comes under flexible automation? The name itself indicating flexible, which is ready to take, ready to change, ready to innovate a new one. If at all I want to prepare a new object with some innovation, then I can directly use that. After completing the task, I can change it. So that is nothing but a flexible manufacturing. Okay, now I am discussing about some of the benefits. Each and everything having benefits, pros and cons. Okay, I'll discuss it later. Now I'm talking about these strategies of automation. So what exactly the strategies here? So for an industry to integrate this automation into its own, we need to follow some set of strategies. First one is specialization of operations, which means if at all my plant is running on its own completely, so I want to implement some specialized operations, which means some pick and place applications or some AGVs, use of sensors, creators. That specialization of operations need to be involved using a special operation equipment for this type of strategy. And coming to the next strategy, that is like a combined operations. If at all I'm having 4 missions and 4 missions are doing same operations but simultaneously. First mission is cutting some removing, and second mission is cutting some other operations, third mission is cutting some corner areas, and fourth mission is removing some material from center. Then what will be happen here? I am integrating the 4 operations, reducing number of operations. I am integrating 4 operations in a mission by reducing the number of operations by increasing cycle time. No problem. Why? Because if at all we increasing the cycle time by reducing the number of workstations, the production will be high. Maybe because we can use that other missions for some other purpose, so we can implement that process in this aspect. So this is the second strategy. And while coming to the other strategies are like simultaneous operations. If at all we are doing, like already explained you previously, combined operations, like these are called as a simultaneous operations. If at all we are doing simultaneous operations in some other missions, which is on some other assembly lines or production lines, that can also be integrated by using this automated for reducing the total processing time. And the next concept is integration of process. So what exactly is this? So integration is nothing but involvement of combination of other processes. Integration of, so where exactly we are here, we are using the maximum utilization of all the missions which are in the assembly line. That is nothing but this integration of operations. If at all I am doing the same operation, same in 4 different missions in some other type also, so I can integrate them and I can increase my time and I can reduce the effort of some other missions. That will be my integration of operations. And now we're coming to the next strategy, that is nothing but increase the flexibility. What exactly is this? Flexibility. So if at all I'm considering this flexibility, utilization of equipment, my milling machine, if at all I'm using some milling machine and I am using that milling machine only for drilling purpose, then nowhere it is useful. Then I can directly use for that milling machine for some milling applications or for pressing applications, and I can use some other machine for this drilling application. That is utilization of equipment exactly to the desired level. And improvement of material handling and storage. So what exactly is this? Improving material handling. So like previously we already discussed, mission 2 output need to be carried to mission 3 input. That need to be improved by the help of conveyors or automated guided vehicles or some other means. And storage systems. If at all I have created mission 2 outputs at somewhere and I need to run on the next day, then I need to store that parts at separate vehicles. That is called a storage tasks. Okay. And some next one is online inspection. This is a main strategy. If at all I am getting some output from mission 1 and mission 2, that output need to be input for the next mission. But before and if at all my output is defect, and what will happen? That defect output was input of the second machine and the process continue. What will happen after completing of the complete process? Then only we will going to discover that this product is having some errors. So by eliminating that type of products, that type of task, that type of errors, so we are using an online inspection, the line inspection. We call it as a line inspection after the completion of after the coming out of output from the mission 1, that is called as an online inspection for correction of the process. And next one is process control. This process control comes to more effectively. Why? Because if at all my process is running on the one assembly line, one production line, and after completing the one production line, it should travel to 3, and that should be by using some effective way that can be discussed further. Okay, that is known as a process control. And further, and the last one is integration of computers in this process. Okay, after integration of this computer, what will be happen? We can directly monitor the production, we can directly monitor the efficiencies of the machines, we can directly monitor the breakdowns. So why exactly the breakdowns will be raised, what exactly the production of the mission 1, mission 2, and what is the time taken for this conveyors, what is the material handling time, how much time is taken for the integration, inspection. These all can be obtained or achieved by integrating this CIM concept. It's integration of factory complete process in the computers. So these are some of the strategies, and each and like I already told you, so every concept is having benefits, pros and cons. Like this automation is having its own benefits, like it is having higher relatability. Why? Because we are producing more number of outputs in higher production rate. That is the major advantage of this task. And second one is increasing productivity. So after using all these aspects, the production rate will be completely increased. With the quality enhancement also, the quality which you are getting by using automation is more is higher when compared to the previous one. Why? Because we are using all the automated parts, and we are using all the automated process here, and we are using CNC technology, and with using all the high level of missions and all high level of performances, we are getting this high rich in quality. Okay, and reduction of routine operations, like unloading, loading of materials from missions or from trucks to the workstations, that can be reduced by using this automation. And further is we can use this automation for creating different interesting lines. If at all my plant is completely automated, still there will be aspect for creating new paths for generating the new interesting ideas. And third one is increasing of production capacity. And if at all my plant is running with some X number of output, with all implement of automation in my plant, I can increase my productivity to some other say X1 or X2 or X3, somewhat greater than the previous one. So this is why we are using this automation in our industries. And the first one is, with the greater flexibility, we can use standard production operations. We can use this, like we are having flexible automation, programmable automation, fixed automation. With this type of automation, so we can directly get the output, desired output. So if at all we want to produce 1000 outputs, we can prepare the 1000 outputs at the desired time. That should be helpful. Why? Because it is called as a flexible. Now we will be discussing, so why we are the reasons for this automation, involvement of automation industries. First one is, if we want to increase the productivity, every industry need to get higher production rates. For getting higher production rates, if we want to increase your productivity, then the automation needs to comes into place for getting greater outputs per hour. So if at all you consider, even now we are considering or comparing this output with the worker output, what will be happen? Here we will get definitely this automated output will be greater when compared to the output human output. Okay, so this is the first reason. And coming to the second, nowadays the labor cost is more, worker cost is more, paying salaries, paying wages continuously will be more when compared to this one. So if at all you install an automated process in the place of these humans, then automatically what will be happen? Our initial cost will be high, but future will get a higher production rate. And safety of all the mission, safety of the humans will be increased with this automation. And while considering about the raw materials, if at all we are discussing about the raw material, what if the raw material cost is higher, then what will be done? We are decreasing the labor, we are increasing the automated parts, and we are getting the higher production rates, we are getting the higher quality outputs, so we are getting the profit also. Then we will invest that profit in the raw material for getting more outputs. So this is one of the reason we are using this automation. And while coming to this lead times, so if at all we are using some process time with this automation, that process time will be reduced and we'll getting the desired output. So this is what the concept of automation. Now with this topic, I'm concluding that automation is nothing but it is an completely involvement of automated parts, automated control systems, everything is automated in an industry. It is called as a substitute of human efforts and human control units. We can directly control that. We can control that human part with the help of some missions or some other components of automation, and we're getting the desired outputs, or we're getting some greater outputs which will be obtained by humans. So automation is a concept that will increase the production rate and increase the safety of the workers and increase the production rates and increase the raw material cycle time and everything. So with this concept, I'm telling that automation is applicable for all industries and it is most efficient way to increase our production in any industry. Okay, thank you.